Let's talk for a moment about what a slope field is. Imagine we had a function f of x, it equals 2x, and if we decide to integrate that function with respect to x, we would find that the antiderivative of 2x is x squared plus c. And what's difficult is coming up with this value for c without some more information. So there's lots of different possibilities for the particular function whose derivative is 2x. One of those possibilities is quadratic to the origin. Another one would be one that's shifted up. A different one, who would also have the same derivative, would be x squared minus 3. We can see that all of these have the same shape, and they just basically have different y-intercepts. They're the same function with the vertical shift thrown in. Well, the issue with the slope field is that it's ultimately a way to consider some function's antiderivative based on what must be true. 2x is the derivative of some function. We could write that as dy dx equals 2x. This is an expression for the slope of its antiderivative at every x value. Which means when we go ahead and sketch in a slope field, we should not be surprised to find that it looks like we have a bunch of quadratic equations. The reason we shouldn't be surprised is because that is the antiderivative of 2x. Notice that when the x value of 2x, when x is equal to 0, then that would mean that 2 times 0 would also be 0. And so everywhere the x value is 0, we're going to have a slope that's 0. We know enough about lines that means that we've got a horizontal line there. So what I'm sketching in is the horizontal tangents to the original curve at that point. And that when x is 1, we would have a slope of 2, which would look something like this. And when x has a value of 2, we would end up with a slope of 4, which would be even steeper. When x is negative 1, we get all of these slopes that have a slope of negative 2. And when x has a value of negative 2, we have slopes of negative 4. And what we should see is that we're starting to see the outline of the curves that we can have. We're not exactly sure which of these possible quadratics we could have, and there's an infinite number of them, but we can see the outline of all of the possible curves. So the slope field is a sketch of all of the graphs that you could possibly have started from. Right? I could have taken the derivative of x squared plus any constant and ended up with 2x. The slope field is a graphical representation of all possible antiderivatives using tangent lines.